All right, so hi, I'm from the UK. My name's Emily. I predominantly work at Bang University. I'm a soil biogeochemist, but I also do quite a lot of livestock science and grass and science on the side. So it's just a picture of my field trial at Bangor on the North Wales coast. So just to quickly run through what we've been researching for the last 4 and a bit years now. We've been looking at sort of reintroducing mixed species grasslands into arable crop rotations, and then the impact on soil quality, livestock productivity, and greenhouse gas emissions. Sweet. So it's a little bit of background to sort of UK agriculture. It's quite disconnected in the sense that it's very regional based. So in the east of the country, we have a lot of arable agriculture, and in the west of the country, it's a lot of livestock agriculture just because of the soil and the climate. But sort of a consequence of that disconnect between the two sort of specialisms of agriculture, we kind of rely intensively on intensive agriculture. So there's a lot of loss of soil organic matter, soil degradation, and issues that come with that from the arable side of the country. Just from the intensive practices that we have to sort of employ to maintain productivity. So a lot of mineral and fertilizers, a lot of agrochemicals like that, which leads to issues such as soil degradation. So we lose soil structure, we're losing the ecosystem services that sort of come with that as well. And we lose soil carbon. That has an impact on declining crop yield, so we have to put more and more inputs in to kind of maintain that crop productivity, which then has negative impacts then on increasing the greenhouse gas emissions. So in particular, we have quite high nitrous oxide emissions. So nitrous oxide is N2O, which is a really potent greenhouse gas. It's about 300 times more potent than CO2. And then also as a consequence of having monoculture intensive crop rotations, we then have a lot of biodiversity loss and habitat loss as well, which we also get as a livestock side of the country through loss of habitat. And then in the west side of the country, where we have our livestock, we also have issues with poor livestock productivity. That's mainly a consequence of sort of inadequate nutrition from feed, so from forage, and that's also a consequence of anti-helminthic resistance, so parasite resistance that's building up in our UK animals, just from overuse of sort of antiparasitic drugs in our livestock. So all of these things combined, the most sort of significant economic cost really in the UK is the soil degradation. So it's between about 0.9 to 1.2 billion pounds annually that we actually lose as a consequence of that. So the UK government and particularly agri-environment schemes are looking at reintroducing grasslands and livestock back into crop rotations to break up pest and disease cycles and to kind of preserve the soil, stop erosion, and then re-put some sort of soil organic matter and soil carbon back into the system as well. So one of the ways that we can do this is through perennial ryegrass swards, which is pure grass, nothing else. But then as a side effect of that, you do have to use quite a lot of mineral and fertilizers to maintain productivity, so you're still producing a lot of greenhouse gases. The alternative method we've got is using what we call herbal leys. So herbal leys aren't just pure grasses, they've also got a lot of legumes in, so clovers, lucerne, things like that, and we also have a lot of herbs in it as well. And that means we can deliver more ecosystem services than a normal conventional sward can. Because we can kind of lock down more nitrogen, we can improve the soil structure, and we can also meet biodiversity targets. So the picture on the right-hand side, that's kind of an example of our sort of herbal ley that we have at Bang University. So the sort of the thin grasses you can see through the sward, sort of canopy, you can see the legumes, which are sort of four-leaf sort of images. And then the wider lettuce-looking sort of plants, that's a plant we call chicory, which is our bioactive plant species that we put into the mixture. And the bioactive plant species are fantastic because they can deliver sort of secondary effects onto the animal. So if you are grazing your land with livestock to be your soil organic matter input, it can reduce the greenhouse gas emissions that are then associated either through enteric methane emissions or through sort of nitrogen losses excreted from urine and dung, which is one of the things that I looked at in my PhD. The problem with herbal ley research is that most institutions and organisations have researched it on a low diversity herbal mixture, so between 3 to 6 species, whereas most commercial mixtures kind of go up to about 18 different plant species. So it's really highly diverse. So it's hard to kind of like upscale what we see in the literature to what practically farmers are using on their land. So as I said, these sort of bioactive plant species that we use in the herbal ley are really critical. So the one on the left, that's sandfoin, the one in the middle, the bluish one, that's chicory, and then the shortish one on the right-hand side, that's plantain. So the sandfoin has sort of methane-reducing capabilities. The chicory, which is the tall one, that can actually reduce the blue one rather, that can reduce the nitrogen excretion, and then the right-hand side, the sort of shortish plant, That can actually reduce sort of nitrate leaching as a soil, so end losses that way, and then indirect N2O emissions eventually down the line. The problem that we have with these species is that they work great in isolation, but when you put them in a mix, they get diluted out. And it's really hard to find any evidence to say that they work when they're in part of like this 18 species mixture, rather than a 50-50 kind of split that you get in the grassland. So we know that they can do all of these amazing benefits, but we just can't prove it yet. So seed companies in particular are fantastic at peddling all these promises to the farmers, and in reality, we don't know what it does. So we came up with all these research questions where we wanted to see what's happening in the animal, what's happening with soil, what's happening for grazing quality and grass quality, and then obviously at the end of the sort of cycle, what's happening with greenhouse gas emissions. So we can see what the carbon footprint impact is if we utilise it in a traditional farm sort of environment. So this is the research project we've been working on for the last 4 years. So we're part of a large industry-funded project, which is called the BBSRC-SARIC project. So it's funded by the UK Biological Biotechnology Science Research Council, I think. And part of that is a industry and farmer-funded aspect, which is the SARIC Club. And we have sites, this started in 2019, we have sites all over Eastern England in the arable areas where we planted up arable fields, grasslands, and then we put sheep on, and we're like, great, we'll measure this over the next 4 years. And then in March 2020, COVID hit. We weren't allowed to travel to field sites. It was very, very difficult to get our project partners to kind of go out and take samples for us, so obviously all the way in North Wales. So we had to change our plans considerably. So we added on Henbuys, which is our North Wales site, which is one quite far away from the east of the UK. And that was where I did the basis of my PhD research, basically. So we can kind of split our, well, I say our, my PhD research into sort of 3 key themes. So the first theme is looking at the impact on grazing quality and forage quality, and then the impact on sort of ecosystem services. So I was quite interested in the impact on earthworm abundance, microbial diversity, and soil structure. And obviously looking at the trace element, micronutrient content of the grasses, and then how they go on to affect livestock. So then we also measured, is this whole theory that feeding the chicory can reduce the nitrogen in the excretion true, or is it diluted out? So we went and we measured the urine and the dung, and then we sort of measured the greenhouse gases so that we could develop an accurate sort of percentage emission factor, which is a value that you use in greenhouse gas inventory calculations for governments and the IPCC, things like that. And then finally, we wanted to assess the health benefits to livestock as well, compared to sort of grazing a conventional grass-clover sward where there's no bioactive plants, or grazing a sort of perennial ryegrass sward, which is quite traditional in the UK as well. So this is where Henbuys is. This is sort of the bottom end of Henbuys, just below the road there. As you can see, it's really, really, really wet, and it's very, very green, so it's very different to Australia. And we are actually part of the Global Farm Platform, which is a global network of farms that are trying to achieve sustainable ruminant production, which is why we're quite heavily focused on sort of sheep research, and that's why I was quite interested in this for PhD. So this is the field experiment I set up. So it was a 2-hectare, 2-year field trial, and we used rotational grazing rather than set stocking so that we can kind of maximise the ingestion of the plants by the sheep. And one of the things sort of on the bottom left sort of V shape, that's the grass-clover paddock, and then the top sort of reverse V shape, that's the herbal paddocks. Unfortunately, you can't really see the different grasses, at this height, but they are there. And we grazed about 40 sheep, Welsh mountain sheep, to see how productive we can make them before they go off to slaughter or if they go to breeding, to see if we can reduce the amount of time it takes them to kind of meet their milestones. And then the little sort of metal silver squares, there are greenhouse gas measuring areas and our soil and our plant measuring areas as well, just so that we're free of any sheep contamination and any sheep damage. So the first kind of finding that we found is really surprisingly that even though we're filling up the herbal load with all these protein-rich plants and sugar-rich plants, there wasn't any difference between a conventional grass-clover sward in terms of nutritional properties, which is quite surprising, because the grass-clover, you'd think we'd outcompete it because we're giving them sort of a salad versus just chips, every day. But the one key thing we did really find is that the micronutrient content and the macronutrient content is much higher in herbal load, just because there's deeper tap-rooting plants that can access subsoil nutrients and bring them to the surface. And also certain plants such as chicory, which is that salad-looking, sort of lettuce-looking leaf, that's better at holding sodium than sort of other plants is, which in turn has impacts on the urination behaviours of the animals as well. And then because we had a massive drought in summer 2021, we decided to make some hay, and we looked at the hay. There's no difference in that either, so it's a bit anticlimactic. So when we followed that through to see how did the lambs that were grazing it getting on, we didn't find any difference in terms of live weight gain, so the amount of fat that they're putting on every day, the amount of muscle that they're putting on every day. In autumn, we only saw any difference in spring. So we had males in autumn because they were finishing up ready to go to slaughter. In spring, we had female lambs that were then going for breeding. We didn't get any difference in the autumn rams, probably because we had quite a bad parasite burden, which I'll show you on the next slide. But we did see an improvement in the spring lambs. So basically, we got them to go faster, so they can finish faster or go for breeding faster. So in terms of parasite burden, the massive selling point of herbal leys in terms of commercial aspects is that you can reduce the amount of anti-parasitic drugs you have to feed your livestock, which obviously a lot of these commercial studies have done them in 50-50 mixes. They don't do them when there's 18 different plant species on the go. So you're getting that dilution, which you're seeing in the herbal ley. So one of the things I wanted to prove was, does it actually reduce the parasite burden, or is it just a marketing link? In autumn, we didn't see any difference in terms of parasites. So we looked at tapeworm eggs, we looked at strong-lead eggs and nematode eggs, all three key parasite species that would have a negative impact on sort of live weight gain and productivity. And we think that could either be because there was no the plant secretary metabolite concentrations could have been lower in the autumn, or it just be because the burden was so bad when we started, it was too far gone to treat it naturally. We had to treat it chemical sort of intervention, which we had to do by week 4, which is why we jumped from that quite high peak back down to get it back into control. But in spring, because the burden was already low, we actually managed to suppress it by the time we got to week 11, which is on the right-hand side with our new lambs. So we managed to get the herbal ley to do it there, which was quite promising to see, actually. And then when we took a blood sample at the end of the spring grazing season, so we only did it once as kind of a proof of concept to see if we could apply for more funding to follow on that way. And we actually found that, surprisingly, even though there was no difference in the swards selenium and the sward cobalt, so both selenium and cobalt are massively important for the reproductive health of the animal and for the nervous system function of an animal. So if you have deficiencies of those, you have bad sort of meat production, you have abortions in the animals and things like that. So we actually found that plasma selenium, plasma cobalt was much, much higher in the herbal ley lambs. So that could be an artifact of them grazing more, ingesting more, and holding on to it better. But in terms of other sort of key markers for micronutrient status, they just didn't change basically the animal. And in terms of sort of general like blood biochemistry, such as energy sort of indicators, because we didn't get those differences that we saw in the plant in terms of sugar content or the free protein content, there was no difference in the blood. So that was really cool to see, because we kind of proved that it does have an impact. And then both seasons, so over autumn 2020 and spring 2021, we measured the excreta of the animals to see if we can reduce that nitrogen. Annoyingly, if you're looking at the total grams of N column, we didn't get any difference in the total nitrogen excreted in urine between the two sward types, so the grass-clover and the herbal ley, which is very frustrating because that's the one key result we really wanted to prove, and it just didn't work at all. So the herbal ley urine is on the left there, which is the one that's very orangey. It looks a bit like cider, and then the grass-clover urine that looks very, very dark, and it's very unhealthy sort of urine, especially for a human being. In terms of the dung nitrogen content, we didn't actually see any difference. So we didn't see any difference to the dung other than the herbal lambs food, bigger poos, basically, which I don't think that's interesting. So the other sort of factor is supposed to reduce the amount of nitrogen they excrete, and then we scale that up into the nitrogen loading rate that's applied to the pasture. So a bit like a mineral end loading rate, it's the same sort of concept. And we found that because we're feeding them so much protein and the sodium that they were ingesting was so high, they urinated bigger volumes, which then drove up our nitrogen loading rate for the herbal lambs to about 1,000 kilograms of N per hectare, compared to about 500 kilograms of N per hectare for the grass-clover lambs. So it did the complete opposite of what we were expecting, and it was a bit like a bullet to the foot, really. And in spring, we got the reverse. We had lower nitrogen loading rate, but it wasn't statistically significant compared to the grass-clover lambs. So there was no difference whatsoever in terms of nitrogen excretion. But the really cool thing that we saw, which I haven't been able to find out anywhere else in the literature, is that the sodium content of urine massively shot up in the herbal ley across both seasons, because obviously the sodium content of what they're ingesting is much higher. but we don't know what the sort of negative impacts that will have on soil sort of functioning down the line. So that's something I want to investigate if I get more time. Probably not. So we applied that urine and dung that we collected back to the soil, and then we measured the sort of soil nitrate, ammonium, sort of pathways of nitrogen transformation. And we also measured the N2O emissions of the greenhouse gas over about 100 days, 120 days. Didn't see any difference in the N2O. There was no response of the soil to any treatment addition that we did. So we did urine, dung and control, and then we applied a low rate of fertiliser in spring to kind of stimulate what would a farmer do if they were allowed to apply like low levels of N just to get the grass started for the growing season. And it was very weird that we didn't get any N2O response, but we think that was because the soil was so dry because we were going through periods of drought quite a lot in that year. That it just was in, suboptimal for N2O emissions. So that was disappointing. So we didn't get any reduction in terms of our greenhouse gas emission factor either. So it's a bit anticlimactic in that sense. It was positive in terms of chick grazing and reproduction because of their greenhouse gases. So in terms of ammonia volatilisation, so when you apply urine to the soil, that initial N will then get transformed, like the urea in that will then get transferred into ammonia, and then you get ammonium coming off as well, which then goes down the rest of the pathway. So about 6% typically of the nitrogen that you apply in a field will get lost as ammonia, especially in the UK. And we wanted to measure to see, can we reduce that just by having different plant species, different N demands, different sort of infiltration rates caused by the differences in the root sort of structure. And we actually did. It was a positive result. It was the first positive result I really got in my study. And we actually found that we managed to cut the ammonia volatilisation in half compared to the grass-clover ley. So in terms of indirect N2O emissions down the line, and obviously ammonia is an environmental pollutant and it's an irritant to human health as well, we actually managed to reduce that. So that was really amazing that we saw. And then the final thing I kind of wanted to do in my PhD was kind of assess the impact on soil structure and on ecosystem services. So I won a access competition to go to the University of Nottingham to use their X-ray CT scanners. And we decided to scan 9 pores from the herbal ley just spread out across the whole field to see what the differences was. And then we tried to target key species within the herbal ley that are notorious for having massive tap roots. So the chicory tap root is supposed to go down to about 2 metres. And it has a lot of lateral roots that just break open that soil structure and kind of increase the soil porosity. And the same for the driftwood plantain as well. So we took 0 to 10 soil cores, which obviously are very shallow, but we're very limited with sort of scanning time and very limited with sort of finances as well. So the cores were initially scanned on a Phoenix scanner. I can't remember which one it was. The Betamax, I think. And then we then broke them apart, air dried them, and then we decided to take 4mm aggregates to assess aggregate stability and aggregate porosity. And then we then did that on a Phoenix Nanoton afterwards. So this is just a sort of demonstratory image of what the root structures look like. So you can see the driftwood plantain, which is the one on the left, it's a lot of thinner roots and it's a lot sort of longer. It has a lot more lateral roots as well, whereas the chicory root is a lot wider and it kind of fractures it open. And that's very lateral roots. Whereas the grass-clover mixture, it was just like having a hairball full of knots. It was impossible to pick it out from the soil, and it's very tightly matted at the top. So in terms of soil porosity, we didn't really see much of a difference. So the image on the left, or the video on the left, that is a heat map of pore size in a herbal ley. So we scanned all the pores, got all the data, and then we decided, great, can we see what the porosity scores were and the sort of pore connectivity networks as well. So you can see we've got a massive earthworm channel there, so we've got a huge biopore in the core. So the brighter the colour, the wider the pore. So at the top of the soil, you've got lots of small pores, not really any difference in porosity because you've got that soil patching for sheep grazing. And then towards the bottom, you're opening up this sort of biopore channels where sort of, worms can move along, plant roots can go through, etc. And then the image on the video on the right, that was just the soil aggregate that we assessed for sort of porosity. And really annoyingly, there was no difference in soil porosity in any of the metrics we measured. We looked at pore connectivity, we looked at the total pore area, pore size, etc. We found no difference between the herbal ley and the grass-clover ley after 20 months of having both lays in place. The caveat of our data set, though, is that we did do it on a grassy soil. We didn't do it on arable soil. So if we went to a soil that was continuously arable, we probably would have seen more dramatic effects than what we did at the grassland site. And from the same field at Bangor, we also decided to assess microbial diversity. Didn't see any difference in that. We were hoping to see some difference because the root structures were different and therefore the root exudates were different, but no, there was no impact in terms of microdiversity increasing. By the same extent, earthworm abundance and earthworm diversity, they were exactly the same. There's no difference from there either. So it's very anticlimactic. So kind of the key take-home messages is that even though there's a lot of sort of commercial marketing saying herbal leys are fantastic in the UK, every farmer should adopt them or pay all these farmers to utilise them, the evidence isn't quite supporting what the companies are peddling yet. We are seeing differences and improvements in sort of the micronutrient and macronutrient content in both sward and the animal. But in terms of the crude protein content, sugar content, there's no difference whatsoever, and digestibility. We didn't find any difference in terms of soil structure using the X-ray CT database. Potentially, if we did go down to deeper pores, we might have seen a difference. Which have to sort of, pay quite a lot to do that. And in terms of ento emissions, because we only had one season, and we had drought in that season, well, 2 seasons in 1 year, and there was quite a significant drought, we didn't see any impact on ento emissions either. But the really positive result is that we did see a reduction in ammonium lactosation by about 58%, which is quite good to see. In terms of the urinary sodium impact on the sheep, it's very peculiar. I mean, it makes sense that they're ingesting more, they should be urinating more sodium. But then the follow-on impact of that onto soil functioning, that's really needs to be investigated to actually know what's going on there. So I hope that was quick. Thank you for all the listening. Funded by a lot of people and I've worked with a lot of people. And yeah, that's pretty much it. Any questions?